we have given that 3 moles of argon is heated from 300 Kelvin to 1000 Kelvin. 3 moles of argon is heated between this temperature. So we need to calculate the heat, the change in heat when P is 1 at and Cp is equals to 23 plus T. Here we have our T as temperature, Cp is the heat, and we need to find the change in heat. So we have also given that the 3 moles of argon has atomic number of 47. So out of that there are 3 moles which are being heated from this temperature to that temperature. We have given an initial temperature and a final temperature. So what we can do is we can simply use the approach of integration, like from initial temperature to final temperature. Here is the 300 Kelvin to 1000 Kelvin. Then we have NCP dt. dt will comes, we are integrating, so dt will be constant. Then we have 23 plus 0.1 T for this. Now we are simply integrating this. How we are integrating is we are simply putting the constant with the variables which do not have constants. So 23 becomes 23T, and this becomes this upon 2, the sum of this, and the 3 comes outside from this due to integration. So now we have to subtract this and subtract this. From that we will come to the value of 61,950 joules per mole, but what we have given here in all this is kilojoule. So we need to divide it by 1000. When we will divide it by 1000, it will become 61.950 joules, which is nothing but 62 kilojoule per mole. Here is 62 kilojoule per mole. This question is very simple. We just need to remember this formula, the formula of heat. We are just finding change of heat, and we have already given this temperature approach, so we just need to do this, nothing more.